Welcome to the September 1 meeting of the Tucson Cactus and Succulent Society. Michiel Pillet is a PhD candidate in the University of Arizona Department of Ecology and Evolutionary Biology. Last year, he opened up a conservation-focused cactus nursery called Prickly Prospects, focusing on propagation of endangered species. His subject tonight is most relevant to the future of cactaceae and maybe even us. His program is entitled Planning for Uncertainty, Conserving Cacti in a World of Change. Mish? Welcome.
Thank you. Thank you very much for having me. So the last time I gave a talk for the Tucson Club, I went a little bit over time, so I'm going to try to avoid doing that this time. I might have gone.
So let's go think about peace.
Almost there.
Counting peace and measuring peace before they had all this automatic stuff. Yeah, great. Well, aspect came out. Spent a lot of time together. It was fun. It was great fun.
I met Pete in 1967.
Pardon?
I met him in 1967. And I started graduate school.
I think I met him earlier.
Yes, you did. You do.
And we did an awful lot with an old coming machine.
Thank you for resolving the technical issues, friends. And thanks for having me. So I'd like to dedicate this talk to James or Jim Pickering. He lived in Tucson for a very long time, specialist in Brazilian cacti. Unfortunately, passed away earlier this year. Awesome.
That was a fast talk.
So yeah, I'd like to dedicate a talk to Jim Pickering, who unfortunately passed away earlier this year. He was a big influence in getting me interested in Brazilian cacti, alongside with Justin Davis, who was one of the speakers earlier this year.
So what are some of your favorite Brazilian cacti? What are some of your favorite Brazilian cacti?
All right, all good. All right, here we go, for real now. Works. Okay, so planning for uncertainty, like technical issues. Conserving cacti in a world of change. That's what I'm going to be talking about today. So 21st century, it's really all about uncertainty. So we don't know what's going to be happening the next 2 years, 3 years, let alone the next 50 years. And that goes for human society as well as for our favorite plants, cacti. And I am particularly interested in conservation. And so conservation in the 21st century really has to embrace a new mindset. And that's a mindset about embracing that change. The extinction rate that we're seeing today is about 1,000 times higher than the background rate. And the background rate is what the extinction rate used to be before people were around. People have estimated that about 1 in 6 species are committed to extinction due to climate change. And with all that, along with all the other issues we're facing, the extinction rate may end up being 10,000 times higher than it used to be. And that reality means that many species need conservation intervention, and there's not enough money to go around to protect all those species. So we're going to have to learn how to let go. And hopefully, we don't have to let go of too many cacti. So a little bit of background about cacti, just very briefly, because you all know a lot about cacti. Well, it's a plant family of about 1,500 species, and new species are being discovered, well, not every day, but probably monthly. Those 1,500 species range all the way from southern Canada to southern Argentina. So all but one pesky species are native to the New World. So here's a graph. There will be a few during this talk. On the horizontal axis, which is down here, this is annual temperature. On the vertical axis is precipitation, so rainfall. And when you think about cacti, you mostly think about deserts, or at least people who aren't very familiar with cacti would think about deserts. And on this diagram, deserts are down here in this little blue circle. All these black dots on this graph represent observations that I've used for my research. They're observations of cactus in the wild and what their climate is, where they're native. So there's a lot of points in the desert, as expected, but there's also a lot of cacti outside of the desert. Here at the top, you've got tropical rainforests. So there's cacti in tropical rainforests. There's even one species out there whose seeds are dispersed by seasonal flooding. Down here, you've got lower temperatures. So not what you typically think of when you're considering deserts. So the only biome that cacti don't really occur in is the tundra, which is all the way down here with low temperatures and low rainfall. Cacti show a very wide variety of growth forms. Columnar cacti like saguaro we're all familiar with, little globose cacti, little strawberry pincushions, barrel cacti, prickly pears, and even a lot of epiphytic cacti. Epiphytes are plants that grow on other plants. Here's some of the diversity. This is Mammillaria herrerae from Mexico, closely related to strawberry pincushion cactus. Astrophytum asterius from Texas and Mexico, which during the dry season almost completely disappears into the ground. The native Echinocereus reichenbachii, which is a hedgehog. This is Opuntia echios from the Galapagos. There's actually quite a few species of cactus in the Galapagos, including a big columnar cactus. Borzicactus semipatanus from South America, beautiful flowers. It's a little shrubby cactus. One of my favorites is Micrantocereus flaviflorus, subspecies alvinii from Brazil. Gorgeous flowers, another little shrubby plant. The columnar cactus Ceres childsii, which we don't know if it actually occurs in the wild. It may have accidentally been created in a botanical garden. And here's Xiabentia verticulata from South America. Once again, not really typical for a cactus to most people. It's actually got leaves. Cacti are also very important for tourism and resource use. This plant over here on the left, Bacchaburgia militaris from Mexico, when it's sexually mature, so meaning it can reproduce, it forms a big hat at the top of its stems. And that hat is kind of fluffy. And so that fluffy hat used to be harvested, and it's not renewable, and used for stuffing car seats back in the day. One of the reasons it's an endangered species. So a little bit about cactus conservation now. Cacti are highly threatened. Mammals and reptiles are less endangered than cacti. They're one of the most endangered groups of organisms on this planet. A few years ago, the IUCN, which is a large conservation organization with different working groups for different types of organisms. I'm a member of the cactus and succulent group for their organization. They did an assessment of the conservation status of every possible cactus species, so a lot of work. And they found that 31% of species were threatened at the time. And a large fraction of cactus species, unfortunately, occur outside of protected areas, so like national parks. Here's one of those epiphytic cacti on the left, by the way, Ripsalis triangularis from Brazil. It was considered extinct for a while, or people thought it might have been, and then it was rediscovered in an urban park in Rio de Janeiro. So this was one of the main results from the IUCN study I just mentioned. This is a graph of all the different threats affecting cacti, ranked by how many species are affected by them. So starting from the left, we've got agriculture and aquaculture. So agriculture makes sense. Aquaculture sounds a little strange. There's actually a species of cactus in Baja that's threatened by shrimp farming. Biological resource use, unfortunately, that includes poaching, which is a very popular topic when it comes to cacti and succulents nowadays. Development, that's something that the Tucson Cactus and Succulent Society is trying to help with, making sure that cacti in Tucson get a new home. Energy production, mining, invasive species like buffalo grass that is choking out baby swallows here in the Tucson area. Transportation, so creating new roads. Human disturbances, for example, farmers burning down patches of vegetation to create room for agriculture. Climate change, all the way at the bottom. Interesting, less than 5% of species being affected by climate change. And then pollution. So, skip over that for a moment and focus on a few species here. This is Monvilea estevesii from Brazil, might be extinct. So it was described in the 21st century, and within a few years, due to agriculture, its only known population disappeared. No efforts have not been successful relocating it. The discoverer actually exported a single fruit abroad to Europe, and the plants germinated. But unfortunately, the person that had those plants then had his greenhouse destroyed by a hailstorm. So the plants are also no longer around in cultivation. Copiapoa hasseltoniana from Chile. So this week, it's been a long day for me. I had to get up at about 4:30 because right now the IUCN is starting a new round of assessments for cacti, trying to figure out how things have evolved in the last 10 years or so in terms of their conservation. And one of the working groups is focused on the genus Copiapoa, which has been in the news in the past couple of years due to large numbers of mature plants being confiscated by customs in Europe. These plants grow really slowly and fetch a lot of money. Discocactus subterraneo proliferans, very long name. Shortly after its discovery on city outskirts, the little city that it was found in, or the little town, started expanding, and its only known population has disappeared as well. So those are two of potentially 3 species that I can think of the top of my head that might be extinct in the wild when it comes to cacti. So the impact of climate change was actually largely unknown when the IUCN did their first assessments. Why might that be? Well, when a plant gets poached, you often see a hole in the ground, so it's pretty easy to tell it's been poached. If a herbivore comes in and eats the plant, you can see some chunks taken out. You can see when a plant dies because a fire comes through, but how can you tell that climate or climate change is responsible for the death of a plant? What are some of the effects that climate might have on cacti? Does anyone have any ideas? Yes, go ahead and speak up and I'll color change. Absolutely, and sun exposure will result in color change. So plants try to stay cool, they try not to burn, and that could impact how fast they grow. Any other ideas? Absolutely. So go ahead. Absolutely. So many cacti rely on boom years to reproduce. So years that are particularly good in terms of rainfall and just weather patterns generally. And so when you have many bad years in a row, which might be due to climate change, one of the aspects of climate change is how extreme events, as they're called, are becoming more and more common in some regions. Well, that might lead to reproductive failure. And if you have reproductive failure, well, then your population won't persist. You might have big adult plants, but no seedlings. So not great for the future of those populations. Or climate can also directly kill a plant. The plant just can't handle it. So it can reduce growth, it can reduce reproduction, or it can increase mortality. So the reason climate change was all the way at the bottom during that last round of assessments was because climate change is notoriously difficult to link to the struggles that certain populations, that certain species are going through. It typically takes a long time to be able to confidently say climate is affecting how well this population is doing. So I'm not going to be talking about climate change in too much detail in terms of what it is at least, but climate is pretty much a synonym for long-term weather patterns. So weather is what you see day to day, and trends in weather, patterns in weather, that's climate. Climate change is then any change in climate over long periods of time, human caused or not. Climate change is always happening. For as long as the planet has existed, climate change has been happening. But, and pretty much every scientist out there agrees on this, climate is now changing very rapidly compared to past climate change due to humans. Regardless of the cause, it is happening and it's happening very quickly. So every species out there is in some way adapted to the environment that it lives in. It's used to certain conditions. And if those conditions change, even in very minor ways, then that might cause those species to no longer do well in the areas that they live historically. So their only two options really are to tolerate the climate, the new climate, move by dispersing seeds, which is a slow process, or evolving, which is typically also a slow process. All right, quick recap. Climate change is happening, global temperatures are rising, and extreme events are becoming more common in terms of dry conditions, prolonged droughts, and floods, hurricanes, whatever you want to think of. What's uncertain is exactly how much temperature will rise. And especially in terms of precipitation, how much is precipitation going to change and where is it going to change? That's very uncertain too. And the focus of today's talk is how many species can tolerate those changes. That's what we care about, right? When we care about cacti. So how will cacti be affected by climate change? And that's what I set out to do these last few years. So if you're walking down the street with this question on your mind and you ask random people, particularly in Tucson, but really anywhere, and you ask them, how will cacti be affected by climate change? Well, a lot of them will probably say, well, cacti live in the desert. They like it hot and dry, so they're going to do great. Or at least they won't be affected very much. Now, if you know cacti a little better, then you might say, well, they're adapted to their historical climate. So climate change is going to impact them negatively. Those are two opposite hypotheses. Now, I'm going to try to not get bogged down in statistics today. So I'm happy to answer questions later about the methods of my study, but I'm going to demonstrate how I address that question with a little thought experiment. So all these points on the map are points I used for saguaro for this research project. Those are observations of saguaro across its range. There's a lot more data in the United States than in Mexico, or at least accessible to me. And then the black outline is the expert map created by the IUCN for saguaro, so where its range is. So a distribution or a range has a size. If that size shrinks, if it decreases, that's bad. If it increases, that's good. Now, these colors represent annual temperature. The more orange on the map means the hotter. Yellow and towards green is cooler. So you can start to notice a pattern here. Saguaro tends to occur in areas that are hotter on the map. Everyone can see that, right? Now let's zoom out. Let's look at Canada. It's pretty cool over there. There's not going to be any saguaro, right? Even if you plant one over there, probably not going to do very well. The same thing with rainfall, annual rainfall. The more blue, the more rainfall. So for saguaro, it's pretty light blue. Not a lot of rain, except for this month. Then over here, that's a lot of blue, a lot of rainfall. Why are there no saguaro over here? Well, if you plant them, they'll probably rot. Now, instead of me doing this verbally, I just sit back and have a computer do this, and that's pretty much what my research is. Don't tell anyone. So I built statistical models that show a relationship between where a species is and the climate in those areas. Then you can use that model to predict the distribution of a species across space, so in different areas, or across time, like in the future, or even in the past. And this is really useful for climate change vulnerability assessments. So climate change vulnerability assessment just says how sensitive a species is expected to be to climate change. All right, so the model then predicts how suitable certain areas are. This is a future map for saguaro. The more green an area is, the more suitable it is. The more red it is, the less suitable. That's not saying that there's not going to be any saguaros in the red areas where they were historically, but climate is expected to be less suitable there. So this is not good, right? So why is this useful in practice? Well, conservation managers, people in general, they want to protect endangered species, right? So historically, people have done this in a very static way. They've looked at where species are and then what the threats are in those areas, but they've disregarded where species might want to be in the future. And that's something that we really have to think about, especially when we're designing protected areas. For example, a new national park. We want to know not only where species are now, but where they want to be in the future. Otherwise, we're going to be pumping a lot of money into an area that might no longer be suitable 50 years from now. Also finding new populations. So for some rare species, you might think, well, there may be more populations out there. So if you build one of these models and it tells you that a certain area is suitable for it, then you could go out and check. And people have found new populations based on these models. Unfortunately, typically when people produce these models, they produce one map, one forecast, one prediction. That's not great because there's a lot of uncertainty associated with predicting the future, right? We're not sure exactly what the future climate's going to be. We're not sure sometimes that the data that we get is 100% right. Maybe someone misidentified a barrel cactus and it was actually a hedgehog. Well, probably not, but. And then also it's statistics. So there's always going to be uncertainty associated with statistics, right? And when that uncertainty is not communicated, that limits the usefulness of these models. So what we really want is a range of potential futures. Based on what's likely, we can then say, well, these are the likely scenarios, so this is what we should do based on those scenarios. So how certain are we of how cacti will be affected by climate change is a very important question. Otherwise, if we're even slightly wrong, then 50 years from now, someone's going to say, well, it's still there. You didn't do your science right. And they'd be right. So for this research project, my collaborators and I looked at 408 species of cactus for which we had enough data, at least 10 points, 10 occurrence points per species. And then we produced 6,480 predictions per species. If you multiply, well, why so many different predictions? To bookend that uncertainty I was talking about, deriving from different climate projections, different statistical decisions, and even things like different migratory capacities. So we don't know exactly how fast cacti are able to move across the landscape. So multiplying these two numbers, you end up with about 2.5 million maps. A lot. The results, pretty shocking. So if you take all those 6,500 projections per species and you average them, then 60% of the species we modeled do very, very poorly under climate change and lose part of their range. And because we have those estimates of the uncertainty associated with that, we can be very confident about this for about 14% of species. Almost a quarter of species, on average, lose over 20%, 25% of their current distribution. It's a lot. You might say, well, great, 40% of cacti are winners. And, you know, on average, that's true. However, we are only confident of that for 1% of species. So there's a lot more uncertainty associated with the winners than with the losers. Now, where does the uncertainty come from? Another graph. The red bars, the little bars, are sources of uncertainty associated with climate itself, so the different climate projections. So the actual magnitude of how much climate is going to change doesn't really matter for the results. Even very minor changes, which are unlikely given the way that we're going, have a big negative impact on cacti as a whole. The biggest sources of uncertainty have to do with the statistics. So it's a good thing that we made so many predictions. And then also with how fast cacti can keep up, how fast they can move by dispersing their seeds and growing up, making new populations. We varied that between 0 miles, so no migratory capacity at all, which is probably pretty realistic for when we're talking about 50 years. 50 years is not a lot of time for a species like saguaro, for example. All the way up to 300 miles. If anyone thinks saguaro can move 300 miles in the next 50 years, well, that would be a very scary future to me. So let's look at some maps. These maps are maps that represent how many species of cactus occur in certain areas. So where are there the most cactus? Well, let's start on the left here. which is the map produced by our models. Well, we see a lot of cactus in Mexico, see a lot of them in Brazil, some other areas. On the right here is cactus richness as predicted by expert maps. So not by a computer, but by people. So they compare pretty well. But that's good. More blue is more species. More purple is more species. Light blue, that's not a lot of species. So not a lot of species in Canada, right? So that's good. That shows that we can be pretty confident in our model's capacity to make these predictions. Now let's look at what the future might bring. So if we average across all the different maps that we produce, and then we look at how richness is going to change for the year 2070, then let's look at some of those hot spots, so the areas of high richness, lots of cactus. Mexico, it's pretty brown. Brown and yellow is a decline in the number of cactus species. So that's not great. Let's look at big chunks of South America. A lot of brown there, right? Also not good. Blue tends to be focused or concentrated mostly in higher latitudes, so where it's cooler. So a lot of cactus will want to move north. Blue means that the cactus richness increases. Now let's focus on the Sonoran Desert here, or at least Arizona. Okay, so we have quite a few species, but we have a little bit of brown, not too bad, and a little bit of blue. The models actually show that on average, most Arizona cacti do pretty well. Saguaro is a winner, according to the models on average. Great, right? Sonoran Desert does fairly well in general. But let's now take a closer look at dispersal, at the migratory capacity and the influence that has on our forecast for the future. Let's start with a map of cactus richness when we assume that cactus can move 300 miles in 50 years to keep up with the climate that they like. 300 miles, a lot. All right, so some good purple in Mexico, that's pretty good, lots of species. Brazil looking pretty good. All right, now I'm gonna go down to 60 miles. That's not that great, right? No purple pretty much. Very light blue across most of the map. So species can't keep up with their climate that they like. Now let's go to no migration, which is probably the most realistic scenario for within 50 years. Almost no deep blue anywhere. Not good. Even the southwestern US is pretty bleak. So those are the main results of our study. What does that do to climate change's ranking on this list? Well, 60% of studied species do pretty poorly, so that would put climate change near the very top of the threats to cacti. Poaching, you can easily do something about. Well, not easily. You can just make sure that people don't poach, right? You can post a police officer next to a cactus if you really wanted to. You could put little microchips in them. But what can we do about climate change? First, a warning. The results from this study are very conservative, which means that the reality is likely going to be worse. There's a bunch of factors these models do not consider whatsoever. One is habitat specialization. Some species rely on certain pollinators, for example, to survive. Some species only occur in certain types of soil in the wild, also not considered. There's a lot of data missing on very rare species. Are rare species going to be doing worse under climate change? We don't really know. It's possible. Migration, once again, the 60% number comes from the average across all those migratory capacities. But in reality, it's probably going to be closer to 0 miles over the next 50 years. Extreme events, also not considered. We have pretty much nothing in the way of forecasts, accurate forecasts for the future for how extreme events are going to change. They're very difficult to predict. When you watch the Weather Channel, it's not going to be able to tell you there's going to be a prolonged heat wave 6 months in advance. So pretty hard to predict. Invasive species also not included. So let's think about swallow again. So with swallow, the model says on average, it's going to do well under climate change. Great. However, bufflegrass. Bufflegrass chokes out the baby swallows. That's not something that's in these models. And that bufflegrass cover is going to increase fire frequency. Swallows don't like fire. So a lot of the big swallows will die too. So that's not considered in these models. So the reality might be quite a bit worse. So what now? Well, historically, people have protected areas where species are right now. And that's still important. But we also have to protect where species will be. And so this is the workshop I'm talking about for the genus Copiapoa that's going on right now. And this is one of the first conservation plans for cacti at a larger scale that's actually considering climate change and thinking about all the uncertainty associated with it. But it has to be considered. A lot of Copiapoa in the wild are doing very, very poorly. And people who are experts on that genus that go out pretty much every day and look at them in the wild are saying, well, these populations are collapsing because there's almost no fog. And Copiapoa rely on fog in the Atacama Desert. Unfortunately, and this is the way I started to talk, is by saying that we're going to have to learn how to let go. And to me, hopefully, that means that we only have to let go of things in the wild in some cases. There's two big categories of conservation. One is in situ, in the wild, protecting wild populations. The other way is ex situ conservation, where plants are grown in botanical gardens, or they're saved and put at the holding area for TCSS, for example. And ex situ conservation will become increasingly important in the future, because these populations, in a lot of cases, regardless of how much money we're going to throw at them, we can't build air conditioners in the desert, outside at least. So we have to conserve things ex situ. Botanical gardens play a big role in that, and botanical gardens should propagate their specimens and also disseminate them to the general public, in my opinion, because that reduces poaching. If plants are readily available, then people will be less tempted to buy poached plants. But also, private individuals do a lot of important work out there. A lot of species of cacti included have been saved in the last few years by private collectors growing these species in cultivation and then eventually even sharing them with botanical gardens so they can build populations of these species as well. So even though in some cases seed is collected illegally, sometimes the end result is a positive one where the species actually persist in cultivation. So it's kind of a double-edged sword. Don't go out there and remove seed though. There's no need to in Arizona. What can you do? Well, let's look at the list of threats again. Agriculture and aquaculture, okay. Maybe slow down on the almonds and cotton in Arizona. Biological resource use, don't poach. Development, maybe we should slow down a little bit and definitely save the plants that are going to be mauled down. Energy, mining, those are all very high-level societal processes that you as an individual probably can't realistically do very much about. At the very least, what you can do is not poach and do not support legal poaching. This is something that happens in the US a lot. People can get permits for the development of private land, for example, in Texas, pretty easily. Dig up all the cactus and then they can actually sell them legally. That's not great. Unfortunately, pretty much every city out there has at least one nursery that sold poached plants, even if that poaching was legal. And that sounds kind of contradictory, legal poaching, but legal poaching can be unethical. Climate change, there's pretty much nothing you can do about it. as an individual. You can make smart decisions in terms of riding your bike and all that. But in the end, it's probably too late for some of these species in the wild. And that sounds very pessimistic, but that's unfortunately the reality. We have to learn how to let go, but we can do our best to not make it worse and protect some of these plants in cultivation as well. So, when I published this article back in April, I got a lot of negative comments. I did some interviews, one for CBS, and they put it on YouTube, and these are some of the responses I got. One thing you can do as an individual is to try to change people's mindsets. I have nothing to gain, for example, by saying climate change is negatively affecting cacti. Nothing at all. I'm a graduate student. I'm going to pay very much. So try to change people's mindsets. Cacti are important. So I would like to thank my lab, my collaborators. I'd like to thank Tristan Davis, who's been one of my greatest supporters over these past 4 or 6 years since I've moved to Tucson. And then, of course, the Tucson Cactus and Succulent Society, which has, well, when I moved to Tucson, I didn't have any cactus at that time. I lived in Montana for a very long time. I collected cactus as a kid back in Belgium, but I had to leave those plants behind, of course. So when I moved to Tucson, some of the good people of the society were very welcoming and got me going with a collection again. So it's kind of gotten out of hand by now. So, and I have a conservation nursery. It's by appointment only, it's in town. But if you're interested in coming to look at some of the endangered species, there's a pretty lady in the back with blonde hair that's got business cards, and feel free to grab one from her or ask me. So I will gladly take any questions depending on the time. Thank you. How are we doing in time? Questions? Okay.
I thought I was good at yelling. I was wondering if you could pair your models with maybe something that exists of like migratory patterns or dense areas of pollinators for cactus. Is that something you could see being used in the future for where to put these kind of areas? Question mark.
So regarding migration specifically for plants, there's very little known. So there are sometimes very rare long distance dispersal events where a seed can travel hundreds of miles. And so those events can be important, but if it's a single plant, it's probably not going to matter very much. But in terms of pollinators, most cactus species are generalist when it comes to pollinators, at least in terms of there's multiple species that can pollinate a cactus. Sometimes it's a specific group of animals, but it's almost always multiple species of that group. And to do that, to do those models, to pair those models under climate change, you would also have to know how are those pollinators going to move under climate change. And someone's actually done this and looked at this for a specific group of cacti, and that was in South America somewhere. And they found that even under climate change, the pollinators would tend to stay in areas where the cactus also want to be. So pollinators are not going to be that big of an issue. If that's generalizable to the Sonoran Desert or worldwide, who knows? It's a very difficult thing to do. Thank you, a great question. Yes. Yeah, so the question was, are there any seed banks that can be donated to? Some. In the United States, the Huntington Botanical Gardens has a seed bank, a cryogenic seed bank, where seeds are stored. And their goal is to have seeds of lots of plants, including cacti, that can in the future be germinated. Yeah, so and for some species, absolutely, and I'm more than willing to put you into contact if you're willing to donate. Some clubs also have a seed depot I know the Central Arizona Club has a seed depot where people can donate their seeds, and then people can learn how to grow cacti from seed. And that's something I very strongly encourage everyone to try at least once. I'm absolutely terrible at germinating and growing anything with leaves. I kill it, guaranteed. But cacti are not that hard to grow from seed, a lot of them. So definitely something to try out. Great question. Thank you. Yes.
What are your thoughts regarding assisted migration? That's a concept that's been proposed recently to help some species get to other places they might have difficulty getting to, given the rapidity of climate change.
Yeah, so assisted migration, for those not familiar with it, it's pretty much taking plants or animals and moving them to a new spot where there may be fewer threats, be it from human beings or from climate change, doesn't matter. Now, one unfortunate thing about scientists is that they're often very, very indecisive. And that's been the case for assisted migration. So there's been a lot of work on assisted migration, but not a lot of people actually want to go out and do it. So even for a single species, people will want to study, well, is this actually one single species? Also, within a species, plants can be, or populations can be adapted to their local microclimate. So if you move a species, even a few miles in some cases, move some plants from a population to a different area where it's slightly hotter or slightly cooler, they may still die. So that's an issue as well. The genetics. The genetic variability can be different in different populations. So you want to think about the genetics as well. I think assisted migration in some cases will be possible. However, for cacti, the very few assisted migration studies that have happened have typically, almost always, to my knowledge, resulted in failure. For Copiapoa, for example, there's been a couple, I think, of experiments. And as far as I know, like not a single plant lived. There's been one successful example in Brazil for a single species, but it's very closely related species where they tried it for that one as well. Didn't work. So there doesn't seem to be a good pattern in terms of whether or not it could work. And of course, if you grow plants in cultivation and then replant them out in the wild, which you should not do not do that. Typically, those plants are pretty pampered. We all like to pamper plants, or sometimes not really. I'll freely admit when it gets hot out, I skip a watering once in a while. Yeah, those plants typically don't do well when planted back into the natural habitat. Great question.